All right, today we're going to be working on something called direct proportion. And it's the name really says it all. It's just when two things are directly proportional. And we're going to talk about the different variables and how we use them and how we determine the important parts. So here's the equation that we use for direct proportion. This is y equals kx. X and y you're very familiar with at this point because they're representing a point on the Cartesian plane. And you know your x component and your y component. K is what's called the constant of proportionality. And the constant of proportionality is basically saying, what do you have to do to x to get y? And it's going to be the same thing every time because k is going to be a constant. That's the name constant of proportionality. So what we could see from this is our direct proportion equation. There's also a direct proportion ratio where if we took our y is equal to kx and we divided both sides of the equation by x, we would find out that k, or the constant of proportionality, is equal to y over x. So we can use either this ratio or this equation to help us solve the problems as we go through. So if you look down at the bottom, there's the first problem we're going to work with. So let's create a little bit of room. And then we'll use the equation. We'll probably just use the equation for now, just to kind of get used to it. You know, kind of like a new pair of sneakers. When you get them, you just want to wear them, try them out, see how it works. Okay, so here's the equation here's the problem we're going to work with, and we're going to make our equation for. So y varies directly as x. What that basically means is you're going to write that y is equal to kx. Because y is going to vary based on what happens to x. And we're also told that x is 3, y is 12. So let's put that in. So we'll put in 12 for y. And remember, when you're substituting, you're always going to be substituting into parentheses. And it's going to be k times 3. And now what we need to do is we need to find k. We need to find that constant of proportionality. So let's divide by 3. And we'll find out that 4 is equal to k. So how that helps us is the next part of our problem is they're asking us, what is x going to be when y is 30? So again, we're going to go back to our original equation, y equals kx. Now, we know from the previous part that k is 4. We also know from what's given in the problem that y is 30. So we're going to have 30 over here is equal to 4 times x. And then if we want to find x, we would divide by 4. So 30 divided by 4, you could reduce that down to make it 15 over 2 is equal to x. If you wanted to, you could make it 7.5. 15 over 2 is an easier number to work with because if you have to do something with x once you found it, you're going to have to turn it back into an improper fraction anyway. Okay, so let's try another example and see how it works. That we can use for our direct proportion. It says y varies directly as x. So again, as soon as we know that y is equal to kx. Let's get my pen going here. And then it says if y is 12 when x is 16, so when y is 12 and x is 16, what will y be when x is 48? So we're going to divide both sides by 16. And we'll find out that 3/4 is equal to k. Okay, so now we found our constant of proportionality, which is something that you want to do in these problems. You want to find out what k is. It's just going to make the rest of the problem a lot easier to work with. So now we have that. So we have y is equal to kx. And then we know y is the thing we're looking for, and that's going to be equal to k, which is 3/4, times x, which is 48. 48 over 1. So we can say y is going to be equal to, and then if you know what 3/4 of 48 is, that's good. If you didn't know, you can reduce this down, say 4 into 4 once, 4 goes into 48 12 times, and then 3 times 12, and we'd find out that y is 36. So just like that, we're able to do these direct proportion problems because they are proportional. All of these numbers are going to make sense. It's going to be reasonable. Once you find k, you're going to know whether is y going to be bigger than x, is y going to be smaller than x. All of those questions will be answered. Okay, so questions that are probably running through your mind is k always going to be a fraction, which it's not. It can be a fraction, can be an integer. It can be a decimal. We prefer it not to be a decimal, but it can be. And for x and y, are you always going to be looking for x? Are you always going to be looking for y? It really doesn't matter which one you're looking for. Once you know k and you're given either x or y, remember you have three variables here. Okay, so we're going to assume we already know what k is. Okay, so k no longer a variable. As long as you're given x or y, doesn't matter which one you're given, you're going to know two of the three variables in the problem. Every equation, if you have one equation, you can only solve for one variable. So in